Second day in a row, I think I've seen snow flying around here in town, and we'll see some more of it today. And there's some good explanation for that we now understand from what we've done in the lecture over this whole course of this semester. So that'll be kind of fun to talk about today. Here's the broad complexion of the weather across the country. Remember on Monday, we were talking about this big region of high pressure building in northwest Canada. It's kind of slid into the central part of the country now, as you can see, all the way into and well past the border of Texas with Mexico. And so this region of high pressure is characterized at this time of year with relatively clear skies, of course. That'll always be the case. But then pretty cold temperatures. And I should have said at this time of year, cold temperatures, both at the surface and at upper levels, can sometimes lead to instability type showers, in this case, snow showers. And so the snow that we've been seeing the last couple of days on and off, and we may see again today, are little convective turrets, little convective storms that force snow to fall out instead of rain. This snow over here, over New England, parts of western New York State, Pennsylvania, Ohio, and West Virginia, that's more associated with an organized cyclone that you can see on the map, anyway, centered over central Pennsylvania. That's a really well-developed disturbance. All these little snow showers, some of which are falling over Madison intermittently, are a result of instability in the lower part of the atmosphere. And I'll show you some really strong evidence for that as we move forward in the discussion today. So one other thing I'd like to point out on this map is, again, effectively taken at random, low, high, and really nice sequence of disturbances across the country. And you know why that's the case now, because these disturbances are spawned by features at levels above the ground in the middle troposphere, and those middle tropospheric wave features are certainly coming in sequence, just like waves at the beach. So there's no difference there in that fundamental characteristic. So we'll say a little bit more later on today about the snow showers in our region, both yesterday and today, and also the widespread cool and relatively dry air that this is going to mean, this region of high pressure over the central U.S. You're going to see high dew point air is only on the farthest south coast of the Gulf of Mexico this morning. So what about the temperatures this morning? Well, they're pretty chilly. We've got 30 degrees at Madison, and this is at 7:30 a.m., 28 at Green Bay, 28 up in Marquette. So the 28 at Green Bay we'll keep in mind in just a minute when we go to another analysis. But look at it, got pretty warm in Boston this morning, 54 degrees, but they're about to chill down into getting into weather more like what we had. The eastern seaboard is relatively warm, but by the end of the day, as that cyclone that's now over central Pennsylvania continues to move to the northeast and drags the cold front across these locations, they will cool down as well. And the only warm remaining spot will be the peninsula of Florida, really. It's even going to get cold all the way down to Brownsville, Texas. Relatively cold, that is. So widespread temperatures in the low 30s across the central United States this morning. This is April 21st. So it's not common to be 31 degrees on April 21st in the morning in St. Louis, for instance, or 34 at Little Rock. So this is an unusual cold spell that we're enduring right now. There's no question about that. And the timing may be bad for certain kinds of plants that, given the head start we had in early April with temperatures nearly at 80 degrees here in Madison and warmer to the south, may have fooled some of those plants a little bit to send out some leaves early that can get kind of pinched back off by the frost. But let's not forget, most of these species have evolved in this landscape for millions of years. They can handle a little bit of a chill in mid-April following a relative warm spot at the beginning of the month. They're not going to really have long-term negative consequences from this. But it is notable. It's cold around here. Remember the 28 at Green Bay. And then here's the dew points. And as I said, with a big region of high pressure sitting in the central part of the United States, not only is the air cold, but since it came from up farther north in Canada, northwestern Canada, it's also very moisture deprived. And so the dew points are low. You have 33 dew points along the coast at Houston. A 33 dew point at Houston is rare at almost any time of year, but especially now. And the peninsula of Florida is where you can have dew points at and above 60 at Jacksonville, 70 Miami's clearly tropical. Everywhere else, moderate dew points at worst. 58 at Cape Hatteras is very modest, 61 at Charleston the same. So not too bad. Rest of the country looking pretty good in terms of moisture content and therefore human comfort. Here's the satellite movie over the continental United States and adjacent waters, and not surprisingly, since we know there's a giant region of high pressure sitting in the central part of the continental U.S., there isn't too much active cloudiness or weather around that looks like it's tied to a weather system. The only exception, perhaps, is this disturbance that, as we mentioned, is kind of at the latest time in this movie over central Pennsylvania. And it does have the characteristic leaf-like shape of the beginnings of a development of a mid-latitude cyclone. It's not really well developed like this one south of Greenland is, as you can see spinning around here on the far right. And then some clouds coming up over the Intermountain West. It's going to be a little bit better organized as the day goes on. We'll see some evidence for why at 500 millibars when we go up there. There's a little bit of a trough off the California coast, as far as I recall. And then most of the country clear. Look how the difference is between where it's cold and clear and warm and clear. And I'll stop it on this last image just to remind you. This is an infrared satellite image, and so the colors here, this grayscale, represents the variations in the radiating temperature that the satellite is seeing. So if the air temperature is cold and there's no clouds, you're going to have gray. If the air temperature is warm and there's no clouds, it's going to be much darker. And look at how dark it is over the Carolinas and Georgia, where we just saw the surface temperatures are in the 50s, 60s, even a 70 down in Miami, but 50s and 60s this morning, as opposed to all 30s back in here with not much cloudiness. But you can see the gray is it's grayer and it's darker where it's warm, so quite dramatic. And just as one other point, the really warm Gulf Stream in the cloud-free skies off the Carolina coast is dark, but look at the shelf waters off New England and the Middle Atlantic, gray, much colder water, and you can even see the edge of the Gulf Stream and all the little eddies in it because the sky is so clear in so much of that region. So the infrared's telling us a lot that you can discern when you're paying attention to all of those different aspects of it. Okay, let's next go to our radar across the continental United States. There's a couple of images missing in this movie, unfortunately, but they don't disrupt the sense that you get from looking at it. That is, the weather over the Pennsylvania, New York State, parts of New England looks more organized than the showery activity that's over our own state. And that showery activity is concentrated perhaps a little bit to the northeast of Madison right now. We may see a redevelopment of that for reasons I'll explain in a minute. And then a little bit of light convective activity over South Florida. And then here's the some of the precipitation falling from the clouds that we saw getting organized a little bit better over Nevada and eastern California. Okay, so that's it for the United States. This is one of those days where it's not precipitating very much anywhere across the U.S. A pretty nice day as a consequence. So let's talk a little bit about these snow showers that we've had. And luckily, this map is terrible, but luckily we have had a problem with data ingestion at the department, and so the maps don't have all of the data that we usually get on them, but we have some of it. And I'm going to concentrate, this is from last night at 7 p.m., I'm going to concentrate on the Great Lakes region. There's Green Bay. Green Bay is one of about 85 stations in the in the 50 states that sends off a radiosonde balloon twice a day. So we get an observation of the atmospheric conditions at Green Bay twice a day, once at 7 a.m. and once at 7 p.m. This is last night's 7 p.m. analysis. And by the time the balloon reached the 500 millibar pressure level, it recorded a temperature of minus 33. You might be able to see those numbers under there. So it's minus 33 degrees C at Green Bay at 500 millibars. This morning's temperature was 28 at Green Bay, so let's call that 0 degrees C or minus 1 degree C. And so there's a 32 degree Celsius temperature difference between the surface at Green Bay, which is not quite sea level, but we'll say it's about sea level, and the elevation that the 500 millibar surface was encountered. And that is registered by these black lines, which are lines of constant height above sea level. And that's what the pseudo-isobars on this map really are. So this is 5.35 kilometers is what the 350 means. So 5.35 kilometers with a temperature difference between the surface, which we'll say is 0 kilometers, even though that's not quite true, and the upper levels is 32 degrees. So that is a lapse rate in degrees per kilometer of, let me get that out in a minute. It's just shy of 6 degrees, or just a little bit more than 6 degrees per kilometer. Okay, so let's see. 32 divided by 5.35, 5.98 degrees per kilometer. So it's about moist neutral. That means that's like the moist adiabatic lapse rate. That's interesting enough. But if we got this much colder, 35, 36 degrees would be even colder than that. And so if an air parcel finds itself saturated, it will be able to rise in this column in freely convective motions. That's pretty interesting. So that helps to produce the showers that we see or have seen the last couple of days. Let's go even more in depth in analyzing this. And we'll do that by going to last night's, again, unfortunately, 925 millibar analysis. So this is above the surface. And the 776 next to Green Bay tells us that the height of this 925 millibar surface is 776 meters above sea level. Okay, and the temperature there was -1 last night. If we then look at 700 millibars at the same time, and here that is 700 millibars, the 913 means it's 2,913 meters above sea level, and the temperature there was -21. Watch what we get this time when we think about the lapse rate. And it's just the temperature difference divided by the distance difference. So first, 2,913 meters minus 776 means we're talking about 2.13 kilometers of distance between 925 and 700 millibars. And we have a 20-degree temperature difference between them. That means the lapse rate is 9.36 degrees Celsius per kilometer, the observed lapse rate. Remember what we were talking about some weeks ago when we were talking about stability. The bigger that lapse rate gets, and this is nearly the same as the dry adiabatic rate, the bigger it gets, the more unstable the atmosphere. Imagine a saturated air parcel near the shore of Green Bay, let's say, that gets itself starting to rise in this environment from 925 millibars to 700 millibars with a lapse rate of the environment of 9.3 degrees. As soon as that air parcel starts to rise and condense any of the water vapor out of it, it's going to be warmer than its environment. It's easy to produce convective showers in such an environment. The consequence is we have a conglomeration of those showers. They seem to be closer to Lake Michigan than away from them this morning, as we saw on the radar. That's the reason. All of this stuff is working in tandem to produce this intermittent showery activity. One other aspect of this is really interesting, is that in between individual showers, there'll be sun coming out. And you can probably see that late this morning. There's going to be periods of cloudiness, periods of a little bit of sunshine. What does the sunshine do? It's absorbed at the surface. It warms the surface temperature a little bit. The temperature at 700 millibars isn't changing much. So we constantly have, when the sun comes out, the stability decreases and the likelihood of regeneration of showers goes up. And when the showers occur, of course, it snows a little bit or rains a little bit. And then the next clearing comes in and you regenerate the instability. So that's what's happening today. It's all exactly like the stuff we were talking about in class over the last several weeks. So quite interesting. And you can really go at this with a fine-tooth comb and get some interesting results from it when you do this kind of analysis. So that's really cool. Here's the satellite movie over the west coast of the United States to get near the end of our discussion. And we can see a really nicely developed storm here in the central Gulf of Alaska. This is a really pretty looking storm. It's now impacting the Aleutian Island chain, Kodiak Island, parts of southwest Alaska. And I want to just show you a couple of things about its relationship to the upper level flow. Our maps don't go far enough off the coast to really give you a nice picture of that. But let's see if we can do that first, and then we'll go to another spot. So here's the upper level map at 500 millibars. I don't think we'll see far enough off, just a little bit. Here's the upper trough associated with the cyclone. So here's the Aleutian chain. Okay, and here's the little trough off California that was spawning some of the cloudiness that I mentioned earlier. But let's go to this series of maps produced by one of my colleagues who used to be at the University of Albany. This is the surface analysis for right about now. Here's our cyclone just off. Here's Alaska, and here's the Aleutian Island chain. So a pretty intense cyclone, and the green shading represents where it's precipitating and how intensely. So you get an idea that this also replicates the distribution of clouds from the storm as well. And then here's the 500 millibar map at the same time. There's a lot of extra stuff on here that you don't need to see. The black lines are the most important. Those are like the equivalent isobars at the 500 millibar level. The blue is vertical motions. Don't worry about that. So I'm going to toggle back and forth between these two maps, and you'll be able to see the relationship between the upper level trough, which is here off the Gulf of Alaska and just about closed off, and the surface cyclone. So that's a pretty nice relationship, very much like the ones we've been talking about all along. So it doesn't matter what stage of the life cycle the storm is in, where it is located, where it's developing, the same relationships apply in every single case. And just out of interest sake, there's Typhoon Suragai. It's now northeast of the Philippines, and And that's what it looks like at 500 millibars, a very sharply cut off vortex. And at the surface, it's just exactly in the same place, and it's an intense cyclone. So a beautiful storm, as you know. And luckily, not too many people suffered its ill consequences.